Hey there, class. Mr. Pusky here. Hope you're having a good day so far. We're continuing with chapter 5 today. We got through the different measures of center for a triangle. We're talking about inequalities in the triangle today. So basically we're looking at like what possible side lengths we can have to make different types of triangles, okay? So yeah, it's kind of a cool lesson. Yeah, it's basically finding what lengths we can have for different triangles, okay? So let's read the name of the lesson is use inequalities in a triangle. Our central question is, by just looking at the angles of a triangle, how can you tell which are the largest and smallest sides? So we have a warm-up here. It says, relate side length and angle measure. Mark the largest angle and longest side, smallest angle and shortest side of the triangle, and what do you notice? Okay, so if you think this is the longest side, you're going to put an L here, okay? That may or may not be correct. I just put it there just to show you. And if you think it's the shortest side, you're going to put it an S. Okay? Go ahead and see how you do. All right. Actually, you won't be able to see what I wrote there, but I put an L in the top right there. Okay? So the largest angle should be up here in the top, and the largest side is on the bottom. And the smallest angle is going to be over here, and the shortest side is going to be over here. What do you notice about this relationship? Well, the largest sides across from the longest sides across from the largest angle, and the shortest sides across from the shortest angle. Does that make sense? If you like take your hands and like you kind of like meet at the wrist, and you kind of like make a V with your hands, right? The wider the space between your hands, the bigger the angle is gonna be, right? So yeah, this makes sense. So basically, they're across from each other. All right. So basically, the bigger the angle, the longer the side has to be across from it to accommodate it. Across from each other. Okay, sounds good. All right, we have some theorems here. So we kind of talked about this. This is kind of an extension of what we just talked about, all right? So if one side of a triangle is longer than the other side, then the angle opposite the longer side is larger, is what? Larger than the angle opposite the shorter side, right? So you can see that A is across from 5 and C is across from 8. Which one's going to be a bigger angle, A or C? Yeah, angle C is going to be bigger than angle A because C is across from 8 and C is across from 8 and A is across from 5. So like if there's a shorter side, it's going to be across from a shorter angle or smaller angle. Okay? And vice versa is also true. Yeah, so if one angle of a triangle is larger than another angle, then the side opposite the larger angle is longer, is what? Longer than the side opposite the smaller angle. So for example, BC is across from 50 and AB is across from 30. So which side is going to be bigger? Yeah, BC is going to be bigger than AB. Okay, makes sense? Yeah, all right, sounds good. All right, triangle inequality theorem. The sum, we'll fill in these blanks here. I'll kind of explain it a little bit in a little bit easier way after this. But basically, it says the sum, what does sum mean? Sum's the addition, right? The sum of the lengths of any two sides of a triangle is greater than the length of the third side, okay? So if you add any two sides lengths together, they have to be bigger than the third side, okay? So this is good. We're just going to fill in these blanks here. AB plus BC is greater than AC. AC plus AB is greater than BC. And BC plus AC is greater than AB. So we're going to put any, put sum, we'll put sum, and let's put addition. Sum of any two sides must be larger than third side. Okay? And a good thing to do is to use the two smaller sides, right? The larger side's also obviously going to work. You want to use the two smaller sides if you can. That makes it easier to tell. Okay? So make sure you write that down if you need to. So the sum of any two sides must be larger than the third side for it to be a triangle. To be a triangle. Okay? Otherwise the sides wouldn't connect. Okay, let's do this here. Example 1. We are, okay, and on the test, people, okay, let's go through the example first. So it says example 1, ordering sides based on angle measure. List the sides of triangle PQR in order from shortest to longest. Okay, so what did they give us in this diagram here? They gave us, what are these? Those are angles, right? I circled them, you won't be able to see them. But yeah, so basically P, Q, and R are angles, okay? So what, for some reason on the test and quiz, what people do is they just go, oh, well, it goes P, R, Q. That's from smallest to biggest angles. I already know that the angles are smallest to biggest because of the numbers, right? We're not ordering the angles, we're listing the sides, okay? We're using what we're learning today. We're not like just listing which angles are bigger or smaller. That's not what I'm asking, okay? I guarantee people on the test are going to do that, and I'm going to point and laugh at them because that's not what I'm asking, okay? Obviously, we can tell which angles are bigger or smaller. What we're trying to figure out is which sides are from smallest to biggest or shortest to longest, okay? So what do you think? Which side is going to be the shortest? Hopefully you said QR because QR is across from 45 and that's the smallest angle. So the shortest side is going to be QR. What's the next biggest angle? It's 55. And 55 is across from what? From QP. So QP is the next biggest side. And what's the largest side? Well, the largest angle is 80. So PR is across from 80. So that's going to be the answer. Okay, so please on your test don't just list which angles are smallest to biggest. You're asking what sides, it might be the reverse too. It might give you sides, you have to figure out the angles, but that's what it's asking. It's not asking for the other thing, okay? All right, that's example 1. Let's see here. Do we have any checkpoints? Okay. So let's talk about example 2, triangle inequality theorem. So it says, will the following side length create a triangle? We have side lengths 4, 11, and 8. I'm going to rearrange them. I'm going to write 4, 8, and 11 just to kind of put smallest to biggest. Okay, so the way you tell if it's a triangle is to check if the sum of the two smaller sides is larger, is what? Larger, not equal to the biggest side. Okay, so what are the two smallest sides out of 4, 8, and 11? 4 and 8. So I'm going to do 4 plus 8 needs to be larger, not equal to, larger than 11. Let's check this out. What's 4 plus 8 going to be? It is 12. Is 12 larger than 11? It is. This is going to be yes. This is a triangle because 12 is bigger than 11. And that's all there is to it. Okay. All right. Sounds good. So next example, find possible side lengths. A triangle has one side of length 14 and another of length 10. Describe the possible lengths of the third side. All right, so here's what we're going to do. It says we're going to draw two triangles. One where the missing side is the smallest side, and one where it's the largest side. Okay, so basically what it's asking for is what's the possible range of values that x can be for the third side. It's asking could it be something like from 2 to x is between 2 and 6. Like, would those be possible lengths that would actually make a third side? That would satisfy what we did up here and actually follow the rule where the two smaller sides are bigger than the third side. Okay? So we're looking for a range of possibilities. And the way we're going to do this is we're going to kind of start with the mins and maxes, the minimums and maximum values. Okay? So we're going to start with one where x is the smallest number. So we're going to put x over here. And we're going to do one where x is the biggest number, or the biggest side. So I'm going to put x over here. Okay, what are the other two numbers we have in this problem here? We have 14 and 10. So I'm going to put 10 over here, 14 over here. And over here, I'm going to put 10 over here and 14 over here. Okay, so now we're going to do what we did before. We're going to take the two smaller sides and see if it's bigger than the third side. And we're going to kind of see what we come up with here, okay? So what are the two smaller sides for this diagram over here? Yeah, so if x and 10. So x plus 10 needs to be greater than, what's the biggest side? 14, okay? How about over here? Where are the two smallest sides? 10 plus 14 needs to be greater than what? The biggest side is x. Now we're going to simplify this a little bit. What's x plus 10 is greater than 14? How do we solve that? We're going to minus 10. Well, just like we were solving an equation, we're going to subtract 10. So we get x is greater than, what's 14 minus 10? It's 4. And how about over here? What's 10 plus 14? 24 is greater than x. Okay, now we need to make a single inequality here. We're trying to make a range of what x can be, what the side can be. Well, x is greater than 4, so I'm going to put 4 is less than x. And then x is also less than it has to be less than over here, 24. Okay, so any number between 4 and 24, would actually make a triangle. That's what this problem is actually trying to find. And by making two triangles where x is the smallest side and the biggest side, we found the possible range of values. So anything between 4 and 24 would make the 14 and 10 triangle actually work, like we talked about up here with the triangle inequality theorem. Okay, kind of complex, but if you follow these steps, you'll be just fine. Okay, we have some checkpoints here. Why don't you go ahead and give these a try. Try checkpoints 1, 2, and 3. Pause the video. Okay, a triangle has one side of 23 meters and another of 17 meters. Describe the possible lengths of the third side. So we're doing possible lengths here, so we're going to draw our two triangles. We're going to do one where x is the smallest side and one where x is the largest side. Okay, so for this one, we have x plus 17 is greater than 23. Okay, that's the smallest side. Then we have over here 17 plus 23 is greater than x. So if we solve this, we're going to subtract 17. X is greater than 6. And over here, that's going to be 40 is greater than x. So for this to work with those two sides, x needs to be between 6 and 40. Any numbers in that range would actually make a triangle. Otherwise, the stuff outside them would not. Okay, example 2 or checkpoint 2. Would the side lengths 3, 4, and 5 form a triangle? So remember, the two small sides have to be bigger than the third side. Let's do it. Where are the two smallest sides here? 3 plus 4 needs to be bigger than 5, which is the third side. What's 3 plus 4? 7. Is 7 greater than 5? It is. This is going to be yes. It forms a triangle. How about example 3? We have 1, 2, and 8. Will that form a triangle? Where are the two smallest sides? 1 plus 2 needs to be bigger than 8. What's 1 plus 2? 3. Is 3 greater than 8? It is not. This is going to be no. It does not form a triangle. It would not be long enough. All right, and that is all I have for you today. Thank you for watching. Have a great day, and we will talk soon.